Many of you have probably been introduced to the quantum realm through something like the Avengers or Ant-Man, which I will be doing a video on soon. But what is the quantum realm really? Welcome to episode 21 of Dylan Explains Everything. My name's Dylan. In case you couldn't tell by the title, I'm the one explaining everything, including the topic of today, the quantum realm. I'm going to be running through a lot of facts, so if you're curious as to where I get my information, be sure to check the description below for a list of links. So what is the quantum realm? Well, before I get into that, I have to explain what quantum physics are. Quantum physics are basically the physics for particles or waves that are too small for normal physics. Several scientists, including Einstein and Schrödinger, have worked on quantum physics. In fact, they're two of the most popular founders. But what's so special about quantum physics? Originally, before quantum mechanics or quantum physics, it was believed that light was a stream of particles, but this was proven wrong in 1805 by the famous double slit experiment done by the scientist Thomas Young. Basically, what Thomas Young did was he pointed a light source at a wall with two slits in it and then looked at the wall behind that. And based on the pattern he saw, he noticed that light doesn't move like a bunch of particles, it moves like a wave. When Young did this again with particles, it acted exactly how you would think. Only a few spots showed the particles on the wall behind it. This was to prove that light doesn't act like normal particles, it acts like water almost in the way that it goes, hence the name wave. However, after this, multiple scientists found different pieces of evidence that pointed to light acting more like a particle like they had thought before, so no one really knew what was going on here. Finally, at some point, scientists recreated the double slit experiment and found something really interesting. Sometimes waves actually acted more like particles in the way they hit the wall, and sometimes particles acted like waves in the way they hit the wall, almost as if they were bouncing off of each other. This created what is now known as wave-particle duality. This created a lot of problems. How can something be a wave and a particle at the same time? In fact, a lot of people have found very sufficient evidence to prove that light sometimes acts like a particle instead of a wave. So at some point, the scientist Schrödinger decided to make an equation to calculate a bunch of stuff with this, which pointed out some weird things. Even though it was mathematically sound, it pointed at the fact that particles could be in two places at once. To this day, that mathematical and scientific fact has been debated multiple times by scientists figuring out what it meant. Some scientists think that there's something bigger going on or something that we don't understand, while other scientists have come up with a theory as to what it meant. If you're into comic books or the Avengers, you might have heard the term multiverse used. This is what some scientists believe is actually happening here. They think that there's two particles that are around at the same time in different universes, different spaces. Even though they're in the same place, they're in different places. If you think back to my time travel episode, I mentioned how there can be multiple timelines in movies when they have time travel. This is basically what they're saying about the world. There could be two universes that are going on at the same time, right? And there could be a particle in both timelines that are the exact same, or in this case, they're just different universes. Scientists also found something pretty weird after particle-wave duality. They found out that if they shot a single particle at the double slits, then it would actually shoot an electron through the other one. Even though scientists can predict things like the way a football works really easily, they could not account for so many things when it came to these small particles. Some scientists have also pointed out another meaning with Schrödinger's equation that it predicted. Basically, if you have two particles, they could be the entire universe apart. But if they're entangled through quantum physics, then if you move one, the other one moves the same way. Basically, what this means is if this particle is over here, we'll call this particle A, and this particle is over here, particle B. Let's say that these two particles are intertwined, they're entangled through quantum physics. If this particle moves downwards, then this will move downwards at the same rate. As scientists were trying to figure all this out and make sense of it, though, they figured something out called the uncertainty principle. Basically, it means if you take something like an electron and look at it, you can tell where its position is, but there's no way of telling where its momentum is. Then, if you look at an electron but look at its momentum, you can't figure out where its position is. And this is the same for particles with their energy and time. I drew this to try and explain it to you. Basically, if you look at particle A here, you can tell where it is. It's right there. You can tell its position. But can you tell which way it's going? Not really. Now if you look at particle B here, you can tell which way it's going pretty easily. It's going this way and it's going relatively slow. But if you were asked where it is, it could be anywhere along here or maybe even further. We wouldn't know. Obviously that's just an example and doesn't show it properly, but it gives you the general idea. When looking at particles, you can only measure one thing and not the other very accurately when looking at them. So now that I've explained some core concept of quantum mechanics to you, let's get back to the main question. What is the quantum realm? Well, the answer is actually really boring. The truth is, in real life, the quantum realm is anywhere where quantum physics apply. In which case, right now, we are all in the quantum realm because our universe has quantum physics. This means that if you were able to go to a different universe in the multiverse that doesn't have quantum physics, then that place would not be the quantum realm. In Ant-Man, they have a bit of a different definition for the quantum realm. For them, the quantum realm is the place where the quantum physics actually apply and where you can see it and interact with it. So if you get very small and you are now part of quantum physics, that would be the quantum realm. It's all around us, but in order to actually access it, you have to be really, really small. This isn't how it works in real life, though. So why does any of this actually matter to anyone? Well, if we can master quantum physics and understand it properly and actually control it, imagine all the stuff we could do. The ability to turn waves like light into particles could mean we could make entire crystals out of just light. In fact, scientists have actually already done this. Another example, the ability to entangle objects at will could help us majorly. I mean, imagine just having to move one object in order to move 100 of them. That would make everything so much easier. And let's say you were trying to talk to someone who's across the world from you. Well, you could just entangle your body with like a robot on the other side. Think of all the amazing things you could do with this. One way that quantum mechanics is helping people already in real life right now is through computers. Normally, computers send information through bytes that are just a bunch of ones and zeros. But using quantum mechanics, you can have bytes that actually have 2 bytes stored in 1. So basically, you could send information that's both a 1 and a 0 at the same time. This doubles the processing speed. Quantum computing might sound like something from the far future, but actually quantum computers have already been made. Scientists have been working on them for years and finally come up with solutions on how to make them so that supercomputers can run calculations twice as fast. All in all, quantum mechanics is huge for future technology and uses, and it's not like it's far in the future. It's happening right now. In fact, scientists say they're in the middle of a second revolution of quantum mechanics. So it's going to be pretty much required in the future to have things like quantum computers. With all that being said, I hope you enjoyed today's video just as much as scientists like revolutionizing physics. And if you did, be sure to let me know and stick around for my next video, which always comes out Saturday at 10 a.m. And if you liked the shorter video like I did today, be sure to let me know in the comments below. And if you have any thoughts, questions, or suggestions, be sure to leave them in the comments below. And remember, my name's Dylan and I explain everything.